What we're going to do in this video is address a question that many of us have had since we first started algebra. Where does the quadratic formula actually come from? Most students simply memorize this string of symbols. I remember myself messing it up in an exam and couldn't get the answer for the simple question it was. But it isn't arbitrary. It is actually the result of a systematic algebraic technique known as completing the square. We're going to think about how to derive the formula ourselves so that you never have to worry about forgetting it again. Alright, let's do a quick refresh on the method of completing the square using a simple numerical example like 2x squared minus 8x plus 4 equals 6. As we seen on the previous video, the aim of this method is to make the left side of the equation a perfect square trinomial. Okay, what we will do first is we should divide everything by 2 to make the x squared coefficient 1. This step is essential. Unless x squared coefficient is 1, we can't create a perfect square by just adding a single constant. Therefore, think of it as taking an easy route to our solution. So, after dividing all by 2, we get x squared minus 4x plus 2 equals 3. Then we isolate the constant, which is 2, so we subtract 2 from both sides and get x squared minus 4x equals 1. The final step will be taking half of the middle term's coefficient, square it, and add that value to both sides to maintain the equality. The middle term, or the coefficient of x, is negative 4, so we divide minus 4 and get negative 2. Then we square minus 2 and get 4. Once we get the squared result, we'll add it to both sides and get x squared minus 4x plus 4 equals 5. Just like that, we got a perfect square, which is x squared minus 4x plus 4 that can be expressed as x minus 2 the whole squared. Remember, minus 2 is the value we got from dividing negative 4 by 2 here. So, once we got x minus 2 the whole squared equals 5, then we get x minus 2 equals plus or minus 5 by taking a square root both sides. Then we evaluate the solution as shown. Since this method can be used for solving any quadratic equation, let's use it to derive a general formula for a standard quadratic equation, ax squared plus bx plus c equals 0. We're going to follow the exact steps we used solving the equation on our example. First, we divide all terms by a to make the coefficient of x squared 1. Then we get x squared plus b over ax plus c over a equals 0. After that, we go ahead and eliminate the constant from the left side of the equation for the process of making it a perfect square. So we subtract c over a from both sides. Then we get x squared plus b over ax equals negative c over a. Now we take the coefficient of x, which is b over a, and divide it by 2, and we get b over 2a. Once we get the half of the coefficient, then we square that result, which is b over 2a the whole squared, resulting b squared over 4a squared, and we add that to both sides. Now we have x squared plus b over 2ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. And the left side of the equation is now a perfect square of x plus b over 2a, where b over 2a is the half of x's coefficient. We can check the perfect square by multiplying x plus b over 2a by itself. Here, b over 2a times b over 2a is b squared over 4a squared. B over 2a times x is b over 2ax. The same goes to x times b over 2a, and we write it here. And finally, when we multiply x by x, we get x squared. When we do the addition, we get x squared. B over 2ax plus b over 2ax is 2b over 2ax, and 2 cancels out by 2. So we get x squared plus b over ax plus b squared over 4a squared. This is similar with our equation, so it is indeed a perfect square. So we express x squared plus b over 2ax plus b squared over 4a squared in the form of x plus b over 2a the whole square, which is equal to b squared over 4a squared minus c over a. When we take 4a squared as an LCM, 4a squared divided by 4a squared is 1, and 1 times b squared is b squared, so we write it here. The second one is 4a squared divided by a is 4a, and 4a times negative c is negative 4ac, so we write minus 4ac. So it will be b squared minus 4ac over 4a squared. Now that we have the squared linear term from the left equaling a constant number, we go ahead and take square root to both sides for the aim of taking x from the square. So when we do that, we'll have x plus b over 2a equals to plus or minus square root of b squared minus 4ac over 4a squared. Make sure, whenever you use square root on a constant, you put plus or minus signs, since a positive number taken out of square root always have two results, a positive and a negative one. Since 4a squared is 2a times 2a, or 2a squared, it can be taken out of the square root as 2a. Therefore, we'll have x plus b over 2a equals to plus or minus square root of b squared minus 4ac over 2a, outside of the square root. Finally, to make x be by itself, we'll subtract b over 2a from both sides and get x equals to plus or minus square root of b squared minus 4ac over 2a minus b over 2a. Taking 2a as a common denominator and rearranging the numerator terms, we get x is equals to minus b plus or minus square root of b squared minus 4ac over 2a, which is the general formula we are familiar with from the start. Just like that, we derived the general quadratic formula from the standard quadratic equation using the completing the square method. I hope the process was straightforward. If you found any of the steps unclear, let me know in the comments below. From this general formula, we can identify the expression inside the square root, b squared minus 4ac, which is called the discriminant, as we discussed in the previous video. We'll now see how it determines the nature of the solutions of a quadratic equation. In the previous video, we learned that the discriminant tells us whether the equation has one, two, or no real solutions. The quadratic formula provides a direct justification for this. We have said that when the discriminant is less than 0, the equation has no solution. And this can be justified in the quadratic formula because the discriminant, which is b squared minus 4ac, is inside the square root. And if it is negative, it won't be defined in the set of real number. Therefore, the equation has no solution. Graphically, the parabola lies entirely above the x-axis if it opens upward, or entirely below the x-axis if it opens downward. In either case, it does not intersect the x-axis, so there is no value of x that makes the function equal to 0, as shown on the screen. Remember, finding the roots or zeros of a quadratic equation means finding the x values that make the function equal to 0, which are precisely the x-intercepts. Therefore, if there are no x-intercepts, there are no real solutions. When the discriminant is greater than 0, the equation has two real solutions. In the quadratic formula, a positive value of b squared minus 4ac produces two distinct values because of the plus and minus signs before the square root. This will result two values by having plus square root of b squared minus 4ac and minus square root of b squared minus 4ac. Graphically, the parabola intersects the x-axis at 2 points, giving two x-intercepts and therefore two real solutions, whether the parabola opens upward or downward, as shown on the screen. Finally, when the discriminant is equals to 0, in this case, the equation will have only one solution, because the discriminant, or b squared minus 4ac, being 0 will result 0 taken out of the square root. Then the result will be same whether we add or subtract 0 to minus b over 2a. Therefore, the solution will be one value, which is minus b over 2a. Graphically, the parabola will be tangent to the x-axis, or has one x-intercept, and therefore one real solution for the equation, as shown. As we've seen, the nature of the solutions of a quadratic equation can be determined both algebraically using the discriminant and graphically by examining how the parabola intersects the x-axis. Remember, whether we solve the equation by factoring, completing the square, or the quadratic formula, the result will be the same, so choosing the one you prefer is up to you. We illustrate this on our previous video by doing one equation by the 3 methods, so I encourage you to check it out. I'll put the link down in the description or attach the video at the end. And we're done. You've just seen that the quadratic formula is simply the general result of completing the square for every possible quadratic, and also seen the justification of the discriminant on how it decides the nature of the solution algebraically and graphically. Hopefully that makes some sense and helps you appreciate the elegance of this algebraic result. If this walkthrough was helpful, go ahead and hit that subscribe button to keep mastering math with us here at Rimetric Walkthrough. Thank you for watching, and I'll see you in the next video.